Hi friends, welcome to my channel. So today I have come up with another previous year question from the PSC Physics optional paper. Today's question is regarding the step potential, and this is a very important because in different years I have seen the questions related to step potential or potential well, such questions are repeating. So we have to give more importance to this portion. So let's go straight to the question. The question is, a beam of particle of energy 9 electron volt is incident on a step potential step of 8 electron volt high from the left. What percentage of particle will reflect back? So let us first of all write down what is given to us. So we know that it is given that there is a potential step. The potential step will almost look like this. This potential step has a height of 8 electron volt. A particle is incident from the left having a energy of 9 electron volt. So how will you represent this potential? This potential is equal to V of x equal to 0 for x less than 0, and it is equal to V0, which is 8 electron volt for x greater than or equal to 0. This is how we represent the potential. So first of all, let us write what is the Schrodinger equation. The Schrodinger equation is given by minus h cross square by 2m d square psi by dx square plus V0 into psi equal to E psi. So let we have two Schrodinger equations. One is for this region and another is for this region. One is for V0, one is for 0. So let us first of all write the Schrodinger equation for the region 1. So this is region 1. So we can write for region 1, this is minus h cross square by 2m d square psi by dx square. Here the potential is 0, so the minus E psi equal to 0. Or we can write d square psi by dx square plus 2me by h cross square psi is equal to 0. This is also we can write down as d square psi by dx square plus k1 square psi equal to 0, where k1 equal to root of 2me by h cross square. I think this is easier for everyone. K1 square is equal to root of 2me by h cross square. Similarly, we can write down this equation forward, the next region where the potential is here. So for that region, we will write it as root h cross square by 2m d square psi by dx square plus v0 into psi equal to e psi. So what we will get it as minus h cross square by 2m d square psi by dx square plus v0 minus e into psi equal to 0. We can write this as d square psi by dx square plus e minus v0, you take the negative outside, into 2m by h cross square psi is equal to 0. This can be written as d square psi by dx square plus k2 square psi equal to 0, where k2 is equal to 2m into e minus v0 divided by h cross square. Okay, so we are given with k1 and k2. Two equations are also given. Now what will be, what we are asked to calculate is the what is the percentage of the particle that will be reflected back. So to calculate the reflection coefficient, this is the percentage, in percentage we have to calculate. So before that we can calculate the reflection coefficient. Reflection coefficient is denoted by R, and it is equal to reflected current density divided by incident current density. So this is not very easy to calculate, let me say that. So this will take long much time. So I will involve this reflected current density and incident current density in another video. So now we can take the ready-made expression which we already have for the reflected current density. Let me tell one more thing. The solutions of this equation, that is the solution of this equation region 1, the first equation we have this one. This is the first equation. For solution of this equation is equal to psi1 of x equal to a e raised to I k1x plus b e raised to minus I k1x. This is a solution in that no potential region, and solution of this equation will be psi2 of x equal to c e raised to I k2x. So these are the two solutions where we know what is the value of k1 and k2. k1 is root 2me by x root square. K2 similarly we have it is equal to root 2me minus v0 by x root square. So now once we solve, we know how to calculate current density J. So substitution the current density corresponding to these expressions, we will get the value of R is equal to k1 minus k2 whole square by k1 plus k2 whole square. K1 minus k2 whole square by k1 plus k2 whole square. This is again we can write down as equal to 1 minus k the whole square by 1 plus k the whole square. Now can you tell what is k? K simply is equal to square root of 1 minus v0 by e. I know this will sound little bit strange how I have arrived. So I already told you I will involve that in another separate video because that will take time. So now for the time being, let us take that the solution, the reflection coefficient or reflection coefficient is given by reflected current density by incident current density, which is equal to 1 minus k the whole square by 1 plus k the whole square. Now from here k is 1 minus root of 1 minus v0 by e. Now v0 is given as 8 electron volt, e is given as 9 electron volt. Substituting in this expression we will get it 1 minus 0.33 whole square by 1 plus 0.33 whole square, which will be equal to 0.2538. Now this did not have any unit because it is a unitless quantity. Now what is the percentage? Percentage of the particle that will reflect back. That's equal to, just take the percentage, 25.38%. I'm not very sure whether everyone could catch this equation. Let us rewind this. So what I have done is, first of all, I have taken the potential step. Here I have taken what is the potential here in a different region. For x less than 0 to 0, x greater than 0 is V0, which is 8 electron volt. Now for that particular region, for x less than 0, I have taken the Schrodinger equation. This is the Schrodinger equation, and from this Schrodinger equation I got the solution as a into e raised to I k1x plus b e raised to minus k1x, where k1 is equal to root of 2me by h whole square. Similarly, this is for region 2. I have taken for region 2 also. So for region 2 also we have we have calculated what is the Schrodinger equation. So here this term is not 0, there is a v0 value here, and the solution is e raised to I k2x. Now from this solution we are at the reflection coefficient is equal to reflected current density by incident current density. Now the current density, I think almost everyone know how to calculate the current density. So substitute that two solutions in current density equation. you will get it as k1 minus k2 the whole square by k1 plus k2 whole square. Now I will rearrange it into 1 minus k the whole square by 1 plus k the whole square, where k is equal to root of 1 minus v0 by e. So just substitute the value 8, 9 in this. You will get the percentage as 25.38. That is almost a little more than 1/4 of the particle will reflect back. This is what this result interpret. Now a complete derivation of the potential well is potential step potential I will give in another video. So if you watch both these videos, you will get how to solve this equation. So okay, let us come back in the next video with a new question. Till then, goodbye.